Assalamualaikum warahmatullahi wabarakatuh. My name is Farrel Fadillah Syafi'i. In this video, I will show you my result from sound resonance experiment. So, what is sound resonance? Sound resonance is an event where an object vibrates due to vibration produced by the sound source. Sound resonance can only occur if an object has a natural frequency that is the same as the natural frequency of the vibrating sound source. Goals: 1. Be familiar with the resonance phenomenon. 2. Understand the resonance tube operation. 3. Calculate the airborne sound speed. Equipment. The first one, resonance tube and piston. Second, audio frequency generator or AFG. The third, speaker. Fourth, temperature. Steps. The first one, measure room temperature with temperature. Second one is connect AFG with resonance tube, then set it with the frequency of 300 Hz. The third, pull the piston from the resonance tube until you hear a hum. Then measure how long the piston is pulled. Pull again until you hear a second hum. And the last one is repeat the step at the beginning with a different frequency. Data. Here's the table. So I get a room temperature for 26.8 Celsius, and I do six different frequency from 300 until 800. Here's the data. The first hum for 300 is 0.290 meters, and the second hum is 0.8060. For the 800 is 0.102 and 0.314. So the length of hum is different, depends on frequency. So it will change over and over if you change the frequency. So here's the data analysis. I'm using the equation y equal mx, which is 2 L2 min L1 equal V power 1 per F. And I got for y axis and x axis. So y axis I got 6, and of course x axis I got 6 too. The first one is 3.3 power 10 minus 3, and the last one is 1.2 power 10 minus 3. For the x axis is 1.14, and the last one is 4.2 power 10 minus 1. So this is the graphic. When you put the data on the coordinate, and it shows the line is rising, depends on frequency. It's from this one until this one. It's rising quickly, depends on frequency. So the next one is the analysis. So tan alpha 0 equal velocity 0 or V0. And this is the equation. Tan alpha 0 equal y2 minus y1 per x2 minus x1, which is 4.9 power 10 minus 1 minus 4.2 power 10 minus 1 divided 1.5 power 10 minus t minus 1.3 power 10 minus 3, which is 350 meter per second. So it's a tan alpha 1 and tan alpha 2 is the same equation like a tan alpha 0. So after I get this three of time, I'm doing to find the velocity average. Velocity 0 plus velocity 1 plus velocity 2 divided by 3, and the result is 344 power 44 meter per second. And this is the deviation of velocity. Absolute velocity 2 minus velocity 0 plus absolute velocity 1 minus velocity 0 divided by 2, which is 330t minus 350 plus absolute 350 minus 350 divided by 2, which is 8.34 meter per second. And this is the K-air, deviation velocity divided by average velocity, powered by 100%, which is 2.42%. So I get the precision from this experiment is 97.58%. For the error I get from this experiment is 1.3%, which means the accuracy I got from this experiment is 100 minus 1.3% is 98.7%. Discussion. The first activity is measuring the room temperature, and the temperature is 26.8 Celsius. According to theory, velocity equals 340 meters per second. I did 6 different frequency variation from the data. It was show that the higher the frequency, the shorter the reverberation distance, or the shorter the hum. Yes, you just pull the piston shorter than before if you add the more frequency. The 800 Hz frequency has the shorter reverberation length of the other frequencies, and the curve so risings depending on frequency. So conclusions. The first one. Resonance is an event where an object vibrates due to the vibration of another object where the frequency of the vibrating object is the same as the source that vibrated it. Then the speed of the sound is determined by the temperature and density of the medium. And the last one is frequency is directly proportional to the speed of sound. So that's for me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.